All right, take a look at this. This is AMD's brand new Navi 48 GPU. It's the powerhouse behind their next generation of graphics cards. But if you look really close, there's something kind of weird about its design, something that points to a pretty fascinating secret hidden in the silicon. And that right there is the big question we're going to tackle. How in the world did AMD manage to make this chip a staggering 25% denser than its main competitor from NVIDIA? I mean, that is a huge leap. And we're going to dig in and figure out exactly how they pulled it off. So let's just put the numbers on the table. NVIDIA's chip, it's very respectable, packing 45.6 billion transistors. But then you look at AMD's Navi 48. Get this, it's actually a smaller chip, but it crams in almost 54 billion transistors. So it's 6% smaller, but has over 18% more stuff inside. You just can't argue with those numbers.
And that all boils down to this crazy number. A 25% increase in transistor density. Now, in the world of chip design, where every single square millimeter is like prime real estate, a 25% advantage is, well, it's almost unheard of without jumping to a whole new manufacturing process. But here's the kicker. Both of these chips are built on the same TSMC 5nm class process. So, what is AMD's secret sauce?
Okay, this is where our investigation really kicks off. To get to the bottom of this, we've got to go inside the chip itself. We are going to deconstruct this die piece by piece and see if we can uncover the architectural secrets that make it tick.
So, first up, let's take a look at the anatomy of Navi 48. Think of this as a guided tour of the silicon, where we'll see how everything is laid out. On our little tour, we're going to be looking for clues in a few key places. We'll start with those huge shader engines. That's basically the engine room, before we check out the memory system, that big chunk of infinity cache, and all the other core parts. Somewhere in here lies the answer. Now, the memory system is absolutely crucial. You can think of it like the GPU's entire circulatory system. You've got the PHYs, which are the physical links to the memory chips, the controllers that act like traffic cops, and that brilliant infinity cache, which is constantly trying to guess what data the cores will need next so it can have it ready to go.
And this brings us to a really fascinating design choice. RDNA 4 actually gets rid of the L1 cache the previous generations had. Now, why would they do that? Well, the most likely reason is that with that huge, super efficient infinity cache, the smaller L1 just wasn't pulling its weight anymore. Sometimes adding another layer of cache can actually slow things down.
Okay, now let's talk about the absolute heart of the GPU, the shader engine. This is the main processing block, and it's home to the compute units, or CUs. This is where all the heavy lifting for graphics and compute tasks actually happens. And like we said, Navi 48 has 4 of these absolute powerhouses. But let's zoom in even further. Inside these things, we find the dual compute units. And tucked away inside them, next to the regular shaders, we find our first huge clues. 2 brand new dedicated pieces of hardware. A new AI accelerator and a new ray accelerator. Now things are starting to get really interesting. And these new accelerators? Well, they are RDNA 4's secret weapons. They represent massive architectural leaps in how the GPU handles AI and ray tracing, and they are absolutely key to understanding what makes this chip so special. You know, the change in AI is just profound. RDNA 3 used this clever software trick on its existing hardware. But with RDNA 4, AMD's moved to dedicated hardware. We're talking real tensor cores, just like NVIDIA's. This move massively boosts performance and adds support for new, super efficient math formats like FP8, which is going to be critical for next-gen features like FSR4 upscaling. And the result of that change? It's just stunning. RDNA 4 can crunch up to 4 times the number of AI operations as RDNA 3. And for certain kinds of data, that jumps to a wild 8x improvement. This is a monster generational leap, and it pretty much explains why some of those cool next-gen features might not make it to older cards. So let's put a pin in it. After all the analysis and with confirmation from AMD, we can say it definitively. Navi 48 has 64 dedicated tensor cores. This is a fundamental shift in AMD's GPU architecture, and it finally lets them go toe-to-toe with NVIDIA on AI performance. But wait, the upgrades don't stop with AI. The ray tracing hardware has also been completely overhauled. RDNA 4 literally doubles the number of ray intersections it can process every single cycle compared to the last few generations. It's just a huge raw hardware improvement. And it's not just about brute force either. AMD is also working smarter. They're using new data structures like this BVH-SATE thing to process ray tracing way faster.
optimizing performance for real-world models and accessing memory more efficiently. It's like a multi-pronged attack to boost that RT performance.
Okay, so we've dissected the chip, we've seen the new architecture. What's the final verdict? And what in the world does all this mean for the GPU market as a whole?
Let's go back and look at the die again. When we compare how Navi 48 and NVIDIA's chip use their silicon real estate, you see some areas are remarkably similar, like the cache and I/O. But AMD actually dedicates a smaller percentage of its die to the main processing cores. Now that points to a more efficient design, but it still doesn't fully explain that 25% density advantage.
And this leads to an incredible conclusion. Even after all this digging, the exact source of that 25% density advantage is, well, it's still a mystery. It's a huge testament to AMD's design team, probably some combination of high-density libraries and optimizations that, for now, remains their closely guarded secret sauce.
But here's what we do know for sure. RDNA 4 is a massive step forward. It introduces dedicated tensor cores for AI, it massively upgrades the ray tracing hardware, and it completely overhauls the entire cache and memory system. This is probably the biggest architectural change AMD has made in years. And the real-world impact of all this is incredible. You see, Navi 48 is technically a mid-range chip, but its new architecture is so efficient that it's competing with, and in things like ray tracing and AI, even surpassing the previous generation's high-end flagship, the 7900 XTX. That just completely shakes up the market and creates some competition, which we desperately need.
And it really makes you wonder what could have been. Just imagine a true high-end RDNA 4 chip with 50% more shader engines. Thanks to new GDDR7 memory, it could have gotten 50% more bandwidth and VRAM on the exact same 256-bit memory bus, keeping the whole design relatively simple and efficient.
And that is the final thought I want to leave you with. Seeing what this mid-range chip is capable of, what could a true, no-holds-barred, high-end RDNA 4 GPU have achieved? And we might not get to see one this generation, but the potential baked into this architecture is undeniable, and it definitely sets the stage for a very, very exciting future.